Right. This pattern may help as well. And it comes back to try-catch and what exceptions you should or shouldn't throw. Now, we've already answered this one, haven't we? What do you do when you can't continue? We've already said throw an exception. And here's the example from earlier, where we've done our database query. PDO has said, hang on a moment, that didn't even run. You've got a problem. And we're throwing an exception. It doesn't matter what the exception is. This is a garbage exception just to fit on the slides. But we say something. We don't let it slide. Now, here's the first question. How often are you catching exceptions in your code? Yep. How many of you do that? How many wrap everything religiously in try-catch blocks? I'm not putting my hand up. No? Ooh.
I don't.
You don't. Fair enough.
The answer is like when you can do something meaningful with it. Right?
When you can do something meaningful.
You can actually.
Well, I'm not asking why you should catch it. I'm asking, do you? Do you actually do it? Do you write that code? And do you write it 100% of the time? Because, of course, we've got our guiding star. I'm going to have T-shirts made of that, I think. I really am. Nobody does anything 100% reliably. So we've already established that the exceptions we throw that we know about, although we may have forgotten because we may have written the code 2 months ago, we're not catching those 100% of the time. Now, I don't know about you, but my PHP code sits on top of this huge tottering edifice of other people's code, which also throws exceptions. And they've built their code on this tottering edifice of other people's code and so on and so on and so on. So you've got all these different programmers whose code could throw exceptions. How many of you catch those exceptions? The exceptions thrown by other people's libraries.
You just catch it at the top level, though, and then...
And then what?
Well, then report that.
And then you report it, OK.
Yeah. So
we're going to come back to that.
One of my websites, I actually get an email every time there has been an exception thrown like that.
OK.
Just come through. And then each day I'll get 20 of them, have a quick glance through, see if there's anything significant that's happening or whether it's just crap input sort of thing.
OK.
Yeah.
That's one way to do it.
There is one I do quite a lot, and that's an SQL exception that I might link to a rollback.
OK. Hold that thought. We've got a slide on that. That's a very good point. But before we get there, do you even know what exceptions the code's throwing that you're calling? PHP code is often terribly documented. It's not like Java, where you have to say what exceptions you're going to throw. I mean, what happens with Java is they then simplify all the exceptions so they're meaningless, because no one wants to type out these long bloody strings all the time. So it doesn't work. But often you have no idea when you're calling a piece of code if it's going to throw an exception or not. Earlier on, we talked about PDO, whether it returns true, false, or can throw an exception, for example. Yeah. But just about nobody catches exceptions they didn't throw themselves. And again, if I talk about larger projects with up to 50 people, that snowballs into a huge, huge robustness issue. So you're detecting errors. The system's saying, I can't continue. And you've got all these different errors coming in, and you don't know what they mean and don't know how to handle them. And everything just collapses in a heap. Right. So what's the problem, though? Libraries. So a library's decided it's got to throw an exception. Does it know what should happen as a result? Anyone think it does? No. Apologies, I'm not meaning to teach anyone to suck eggs here. This is an important point to do with scoping that a lot of people overlook. And a lot of people overlook about what a library is and its whole nature of a library. So the whole point of a library, it has no idea who's calling it. All right, I mean, you can look at the debug stack and cheat, but it doesn't necessarily mean anything. By its nature, it's accepting input from the outside world, for anybody and anything at any time. It has no way of knowing or controlling who's talking to it, especially in a language like PHP, which is not modular. We've only got basic OO semantics. We haven't got the ability to say this code only exists inside this module, the outside world can't call it, like some languages do. It'd be nice if we had that one day, but I could talk about that for hours. Right. So a library has no idea what's going on. But a library does know whether or not it should fail. Because the library is where the algorithm is, that's executing. It's looking at the inputs, it's looking at the outputs. So it can safely make the decision whether or not a failure has occurred. Because the library owns that piece of work, if you like. So there's nothing wrong with a library deciding to fail. But what happens next, that's the app. The app owns that. In the old days, we used to call that policy. I don't know if that term's used these days. So policy is where you're deciding what happens, when it happens, whether it happens or not, which libraries you call, whether you call them or not. And because the app knows the business context that you're doing, what the business rule is, what the situation is, whether you've got a database open or not, you're halfway through a transaction, for example, the app's got the information to decide what to do. And we call that policy. It's one of the reasons why you've got to be very careful when writing libraries. They're supposed to do a job and just work or fail. They're not really supposed to be opinionated. Opinionated libraries are policy, and it's in the wrong layer. Policy belongs in the application code because it knows what's going on. So here is our little query again. That currently throws an exception. And we're going to change that. What would it look like if we injected policy into that function? Anyone got any idea how we might do that? How do we tell that function what to do when a failure has happened?
You could pass in the exception that it could.
Pass in the exception. I've done that. I've done that.
Could you give it a failure handler, like a callable sort of thing?
Give it a failure handler. That's the thing I've started to move to this year. So in the past, I've been passing in exceptions, telling it which exception to throw. But that's not necessarily enough because it's still relying on me somewhere else, remembering that I'm throwing that exception and catching it. So instead, what I've moved to is passing in a failure handler. So the library decides whether or not a failure has occurred, and then it calls it's a callback. So it's good old-fashioned PHP callable. And it's provided by the app, and the app decides what happens. That's what you can do. So at this point, this code now is a very good library in robustness terms, assuming we're checking the inputs properly, of course. Because now we're making sure that if an error has occurred, we're not relying on anyone catching the exception and doing the right thing with it. It's being told exactly what should happen when something goes wrong. And we're being forced to write that, because if we don't provide that, PHP is not going to run the code at all, and we'll get a different type of error, and the code won't run. And you won't even get your correctness passing. Now this is really what inversion control is about, inversion of control. You may have heard that term to do with dependency injection containers, where you tell a class what to use for dependencies instead of it creating new instance of objects itself. For me, this is closer to what inversion of control is all about. We're telling the function what to do in situations. It's detecting the situation, and we're providing handlers to deal with it. So for me, this is really much more what inversion of control is than dependency injection. I'm not saying don't use dependency injection. It's great. It makes your code so easy to test by comparison. But inversion of control, think of this more. Tell code what to do in circumstances. And you can actually do quite a lot with this. So one thing I'm doing with this, in this data API I've been talking about, is when an error is detected, I'm actually building the HTTP response at that point, because I know why I've called my functional method. And so if it fails, I know what that failure means in terms of returning back to the user. And here's an example. So this is, excuse the, I was trying to squeeze it on the screen. So this is called from some production code from this morning. And this is a failure function. So I've created an anonymous function, passing in some variables from the outer scope. And first thing I'm doing is I'm rolling back the database. I know I'm in the middle of a transaction, and I know the transaction has to be aborted. And we are going to come back to that. I'm creating an error message to go into my logs. And then I'm actually creating the HTTP response to go back. and I'm attaching that HTTP response to the exception I throw. And I've got a big try-catch block at the very top of my code that looks for this particular type of exception, because it knows if it sees this exception, the exception has the response pre-canned and built to send back to the user. So that whoever's called my API gets the right response. They don't just get a generic everything's failed response. They get told exactly why. In this case, I'm actually using this for input validation. We're looking up a document via its ID, and if the ID is not found, we say, sorry, input validation's failed. You've sent us something we haven't got. And it's a 422, not a 404, because it's part of a piece of data that's been sent in. So it's input validation, it's form validation. It's not a URL where you'd send a 404 back if you can't find it. That's why it's a 422 back. But that's what we're doing. So we can do a lot. You're in these error handlers, you're limited only by your imagination. You can do so much in there. And you can make sure that when failure happens, you're doing the right thing. Because the app knows why I'm making the call. So at that point in the app, you can write the recovery code that's needed. Because you know exactly where you are in the app when the failure happens. And that's really powerful. Because your failure recovery is context specific straight away. You're not doing something generic where you've got to go, oh, I'm in the middle of a transaction. What's the state of my database? What's the state of the session? What's the state of any cookies I've maybe been building to send out? You know exactly where you are, and you can write the code for the situation you're in. It's very powerful. The other thing you can do with this, it doesn't have to throw an exception. And I've been banging on about exceptions, but in some failure situations, sending back a default return type instead might be the right answer. And there's nothing wrong with that. We do this, for example, in scalable systems where so we've got an architecture of services. If one of those remote services has died for any reason, we don't want to take the whole website down because someone else's system's gone down. So we might return a dummy value, or we might put something in there to say that system's unavailable, but the app as a whole may continue and may know about these values. It's one of the ways we keep services online at scale. So sometimes a return value is the right thing for a failure handler to do instead of an exception. Depends on your circumstances. Again, you're limited by your imagination. So this is pattern number 3. And I call this, tell me how to fail. Support a callback. Pass that, inversion of control, pass that in. It can let it throw exceptions. Do not wrap that in a try-catch block in your function when you call the error handler. Don't do that. But let it return a value instead if it wants to. Give it the choice, because that's policy. That's the app's domain, not the libraries. Do that. It's very flexible, very powerful. Now, this is a technique I've only been using for a few months. I'm still learning the consequences of it, the pitfalls of it. But so far, it's allowed me to write a data API that when an error occurs, it returns the right thing every single time to the end user with no problems. It allows me to clean everything up, which we're going to come on to in a moment. And it allows me to do that in a lot less code. And the last thing you want is for your exception handler to have to do a lot of cleanup work in, and it triggers more bugs and more robustness problems, especially if you're dealing with a service that's in a bad state to start off with. So the more you can be targeted on your recovery code, the more likely it is that your robustness code will run without errors. It really helps, in my experience.